For our first question, given the following argument, if Siti wants to study mathematics or she wants to do homework, then she will pass the examination. The question asks us to write the three primitive statements using the letters P, Q, and R. Hence, write all the premises of the arguments above. First, we need to identify the primitive statement. P is Siti wants to study mathematics. Q, Siti wants to do homework. R, Siti will pass the examination. So, by answering the question, if Siti wants to study mathematics, which is P, or Siti wants to do homework, Q, is true, then R, Siti will pass the examination, must be true. So, the form would be P, if P or Q, then R, which is the argument that is written on the slide. For the second question, given if neither Q nor P is true, then P is not true. Construct a truth table and determine whether it is a tautology, contradiction, or contingency using a truth table. Based on the truth table that we have done, we can see that if neither Q nor P is true, then P is not true, is always true. Therefore, it is a tautology.
So next we will be discussing about question 3, which involves determining the logical equivalence of two statements using truth table. First, let's look at the problem. We are given two statements, P then Q, and P and not Q. Our goal is to determine whether these two statements are logically equivalent. To do this, we'll use the truth table. Let's go through the table step by step. The truth table lists all possible truth values of P and Q. Here are the columns we'll be working with. P, Q, P then Q, not P, not Q, P and not Q. Now, let's consider all possible combination of truth values and for P and Q. For row 1, P is true and Q is also true. For row 2, P is true and Q is false. For row 3, P is false and Q is true. For row 4, P is false and Q is false. Next, we'll fill out the column for P then Q and not Q. P then Q is false only when P is true and Q is false. In all other cases, it is true. Not Q is simply the not Q is simply the negation of Q. Finally, we'll determine the truth table P and not Q. P and not Q is true only when both P is true and not Q is true, which means Q is false. Let's review the filled truth table. For row 1, P is true, Q is true. It is P then Q is true. Not Q is false. P and not Q is false. For row 2, P is true, Q is false. P then Q is false. Not Q is true. P and not Q is true. For row 3, P is false, Q is true. P then Q is true. Not Q is false. P and not Q is false. For row 4, P is false, Q is also false. P then Q is true, not Q is true. P and not Q is false. Comparing the columns for P and Q and P and not Q, we see that the truth values do not match in all rows. This means that the statement P then Q and P and not Q are not logically equivalent. In conclusion, the truth table shows that P then Q and P and not Q are not logically equivalent.
Alright, moving on to question 4. The question is, prove the following expression using rules of logic. If P and not Q implies not P, if and only if P implies Q. Alright, how to solve this problem? To prove the given logical expression using rules of logic, we start with the expression if P and not Q implies not P if and only if P implies Q. First, using the implication law, we convert the initial expression into not open bracket Q and not Q close bracket or not P. Applying De Morgan's law, we change it to not P or not Q or not Q or not P. Simplifying the double negation gave us not P or Q or not P. Using the idempotent law, we simplify this further to not P or Q, converting this back using the implication law. We get P implies Q. Therefore, we have shown that if P and not Q implies not P is logically equivalent to P implies Q, thus completing the proof.